ocean environment. We look onto the gas. Temperature, pressure have very different relationship. Temperature. Whenever the temperature increase, gas solubility decrease. And this rule we learned earlier as we learned on carbon dioxide equilibrium as well as dissolved oxygen rule. Now let's look onto the temperature once again. On this graph it shows on x-axis the temperature from 0 degree to 10 degree, 20, 30 and up to 100 degree. You find that the lower the temperature, the more gas able to dissolve. 0 degree, most gas can dissolve. But when you go to 10 degree, the gas start not so soluble. And then 20 degree, less soluble. 30 degree temperature, even less soluble. So here to explain, temperature increase, gas soluble will decrease. Now look onto the pressure side. They have quite an opposite relationship. And here, x-axis is the pressure. 1 atm, 2 atm, 3, 4, 5. The higher the pressure it is. You find the higher is the pressure, the more the gas is soluble. So higher is the pressure, the more solubility is the gas. So you see these two relationships, they run opposite. Higher temperature, less gas soluble. Higher pressure, more gas soluble. It applies to all gas. Now let's focus on oxygen and carbon dioxide because these two are main that we concern. Let's look oxygen. You look onto the ocean. The upper layer, the surface water, they are super saturated with gas, oxygen gas. Why? Because of the wave and the wind, they chunk and churning and make the more oxygen soluble in water. Second, the light can penetrate, so if photosynthesis can take place, which provide oxygen to the fish and plant. But when you go onto the deeper layer, now no more photosynthesis. So photosynthesis stop, oxygen will deplete. So now this zone, oxygen will decrease and getting less and less. On the deeper zone, this zone is only applied to those polar regions, not on the whole ocean. On those polar regions, you have a special phenomena. You find that the deeper is the deepest ocean, suddenly you have more oxygen up here. This strange rule is because called the thermohaline circulation. The reason of it is because when water become colder and getting more salty, and they will getting more concentrate, and this carry oxygen air, carry oxygen water on the surface will sink down to the deep bottom. So it carry the oxygen from the top down to the deep bottom of the ocean. So the salty water will have much higher concentration of oxygen into the deeper ocean. But keep in mind, this I'm talking about the polar region. As in general, you can see oxygen in the top layer dissolve, and onto the deeper is the layer, it getting less and less soluble. And if you not talk the polar region, you can say the deep ocean oxygen are very depleted, lack of oxygen. Now we look onto the carbon dioxide. Carbon dioxide have a very opposite relationship with oxygen. And the carbon dioxide increase in deep ocean, and actually 70 times more concentrated in the ocean than atmosphere. All the carbon dioxide are quite soluble. Why? Because most living organisms, they are made of carbon dioxide carbon backbone. And the carbon dioxide released or the carbonate decompose as a waste which contain carbon dioxide, and which they will go onto the ocean and sink deep. So carbon dioxide content always increase. And on those deep ocean, where the carbon dioxide end up, they will deposit as the shell that you will find it onto the deep ocean, calcium carbonate. So when predicting a rate of corrosion in a deep sea, imagine if there is a ship sink down to the deep ocean, would they rust or not? First, we consider the temperature. The temperature are low. Second, oxygen. The oxygen also very low. So, and it will be high in salt. And the pH roughly about 8. So, in case if it is low in oxygen and is such a cold temperature, remember, cold temperature make chemical reaction slow down. So in that case, rusting should proceed very slowly. And this is what they predict any deep sea ocean. If a ship sink down to the deep sea, they should not rust. And when it happened that on the Titanic ship, and when they dig up the Titanic, they find it rusts very, very badly. So they find that it is not as they predict. And then why would it rust so badly? In the deep ocean, so cold and with no oxygen, to take no oxygen. So how can it rust? And you find because of this sulfate reducing bacteria. As with the definition of rusting, corrosion is the oxidation of metal due to the environmental agent. So iron oxidize. If iron oxidize, if you look onto the standard reduction potential table, and you will find where would it reduce to? Normally we reduce to the oxygen and water to form into hydroxide. This is our normal rusting. But now in the deep ocean, you have no such rusting. So where would it oxidize by? So you have this sulfate reducing bacteria. So the oxidation is the iron. And the sulfate reducing bacteria, they're using the sulfate in the deep ocean combined with water and form into a HS and the OH minus. And that's how this sulfate reducing bacteria form rust.